For example circuit number 9, we're going to look at another way of producing output from our Arduino circuit. In this case, a piezoelectric buzzer unit, which will produce sound depending on the electricity that passes through it. So, as with some of our previous ones, the actual control schematic for this is fairly simple. We just take output from pin number 9 and we feed it through our buzzer unit, which is then connected back to ground. So if we flip over to the actual circuit, as you can see, we've got our piezo buzzer unit here, and it's connected to a control unit, which is then connected back to ground. And the only thing to think about when you're looking at one of these is that your piezo unit is, like LEDs, directional. It's got a positive side and a negative side. The positive side is indicated by a little stamped positive symbol on the top of the plastic covering the piezo buzzer units, and you put that side, or you feed the control pin into that side, and you feed the control pin, in that case this is the black side here, into this side, and you hook the other one back into ground. So, the circuit's fairly simple. Let's head over to the sketch and see what you actually need to do to control the output for this thing. So we've got our buzzer control sketch, and one of the things they note up in the comments at the top is a list of notes and the frequencies they're going to be converting those notes to. That's going to be included as part of a function later to convert this note title over to a frequency. So first, they define their buzzer output pin as pin number 9, and then they define the length of the song they want to play as being 18 characters. And next, they define the notes that song is going to play. And they use a string of characters to indicate those notes, and with spaces indicating a rest, so don't play anything on that. Don't play anything when you pull up that value. And finally, they create an int array of beats, which is how long do I hold that particular note once I'm playing it. And last is int tempo, which is how quickly you want your thing to play through this song. So during the setup, they set the buzzer pin number 9 to output, and we move over to the actual body of the program. They define two variables at the start of the program, I and duration. And for I starts at 0 and goes to 1 less than song length, increase by 1 each time. And they set duration equal to the beats of I times the tempo, which will get you the length of the note or rest in milliseconds. And then they do a check. If notes of I, so if your note is a rest, then delay for a duration. Otherwise, tone, buzzer pin, frequency, pass frequency, notes of I, and duration, and then wait for the tone to finish. So, tone is a command that you pass it the pin you want it to play and the frequency that you want that buzzer pin to, or you want that piezo buzzer to put out. So this is an inbuilt Arduino command for use with the piezo buzzer. And to use it, you need to know what your control pin is and what frequency you want to put out. Actually, that's 3 parameters. The pin, the frequency you want to put out, and how long you want it to play for. So frequency passing notes of I is a function, So int frequency receiving character note. So int I, and then constant int, the number of notes that we're storing, is 8. So this function first defines a parameter or a control variable I, which they're going to be using for our for loop later, and the total number of notes they're looking at in this case is going to be 8. So there's only 8 notes stored in this function. So the character names that it's going to be looking for as valid inputs are lowercase c, lowercase d, lowercase e, lowercase f, lowercase g, lowercase a, lowercase b, and capital C. And then it defines int frequencies associated with that as 262, 294, 330, 349, 392, 440, 494, and 523. So it's going to get passed a character, and it's going to say, for a for loop where I starts at 0 and goes through the number of notes stored, 1 less than, because we're working with arrays, the first index is 0 and the last one is 1 less than the number of elements in the array, incrementing by 1 each time. If one of those matches the thing that we've got, so if one of those matches the input we've got, the character that was passed in, then return the same frequency that's associated with it. So if we get passed in E, that's the third one on the list. So go to the third frequency on the list, 330, and return that. Otherwise, if you don't find anything, return 0 for this function. So that's a default, and you need to return a value, so you just return 0. And then you kick back up here, where the program then waits for the tone to finish, and then waits for tempo divided by 10 milliseconds, just as a pause between notes to make sure that they're distinct. Now, this final line is included while true, and then just completely empty space. This will essentially hang the program. It will reach while true, and then sit there doing nothing forever. So this will make sure that we only play our snippet the one time, and then the program will just wait, and we'll need to reload it if we want it to play the song again. If you want it to play on loop, you can replace this with, say, a simple delay, say wait a second, and then it'll go back up top and play again. Or if you remove this completely, it should play your song snippet back to back to back to back. Now, up here we have the song snippet, and I've actually altered some of the notes in this, so it should no longer be a fragment of any specific song or anything. It's just basically a series of notes. And as we've just got this piezo buzzer hooked in, and it's not going to move or anything like that, we're just going to leave it over the sketch. And I'm going to upload this, and you'll be able to hear the piezo buzzer just output some sound. So, uploading. So it plays the notes that it's been told to play, and then it hangs at this while true forever. Technically, my program is still running over there, but it's just frozen on while true. So if I were to switch that to, say, delay 1000, it's going to wait 1 second, and it would just continue to play that on loop. So if we upload that, and it's just going to play that forever, or at least until I disconnect the Arduino or tell it to run a different program. So I'm going to upload a blank sketch, and that'll stop it from making sound. But that's it. That's how you can get your Arduino to essentially play various sounds. And while you probably won't want it to be part of an orchestra for you, you can use the same sort of thing to create a buzzing or a buzzing indicator to go with your flashing light that says, hey, something about this needs your attention.